So today we'll be doing sums on compound interest. Let's take the first sum. Compound interest on a sum of money at the rate of 5% PA, which stands for per annum, that is 5% per year for 2 years, is rupees 246. Find sum. So they have said that the compound interest for this amount of, for this interest rate and for this amount of time period yields me rupees 246, and I need to find the sum, which essentially means I need to find the principal amount P. Now, if you have paid attention to the formula for compound interest, you might have realized that there's no such formula for compound interest. That is, we don't have a formula for compound interest. We have a formula for the amount that we get when compound interest is applied. So we get the formula for amount. Now we know that amount is essentially principal plus interest. So if we need to find the interest, then that would be A minus P. So we'll get the compound interest to be the amount minus P. Now we know the formula for amount, which is given by this formula. So it's P times 1 plus rate of interest by 100 raised to the power the amount or the time period under consideration. So they have here, for this sum, we have the rate of interest given as 5% PA, so 5% per year. And they have given the time period to be 2 years. So what we do is essentially we replace the rate of interest with 5 as given in the sum, and we replaced T with 2, and P is what we need to find. So this P is my unknown variable. This P is my unknown variable. And they have given me that this part of the expression that stands for amount minus this principal. So as I know, amount minus principal is interest. So this part, this entire bracketed portion will give me the compound interest that I want. And they have said that the compound interest is 246. So I've equated the compound interest with 246. That is, amount minus principal equals 246. In the next step, I take P common, and then I get in brackets 1 plus 5 by 100 raised to the power 2 minus 1 equals 246. What I do is I break it into parts using the formula A plus B whole square equal to A square plus 2AB plus B square. So this 1 and 1 can get cancelled. And what I do essentially is, you can see this is an equation in P. So I can easily find out the value of P by putting down the values and calculating. And what I get is P is 2,400. So this sum essentially says that if I invest 2,400 for 5 years at a compound interest for 2 years, sorry, at a interest rate, compound interest rate for 5% per year, and running for 2 years, I'll get a compound interest, only the interest part, as rupees 246. So that's the first sum. Next sum is, what sum will amount to rupees 2782.50 in 2 years at compound interest if the rates are 5% and 6% for successive years? So what happens is, usually in our previous sum as well, we had one single rate of interest which was applied for both the first year and the second year. But here what we have is, in the first year, the interest rate considered is 5%. But in the second year, the interest rate considered is 6%. So we have two different rates of interest which are applied on 2 different years. So the page was glitching. So yeah, so we have 2 different interest rates for 2 successive years. So what we do is essentially, if you remember the formula that I had discussed before, for 2 different rates of interest, we have P times 1 plus 1 rate of interest by 100 times 1 plus another rate of interest by 100. So essentially, if we have 2 different rates of interest, we have P by 1 plus the first rate of interest by 100, and with that we multiply 1 plus the second rate of interest by 100. So that's essentially the formula for the amount that is accrued when compound interest is applied, and we have 2 different rates of interest in 2 different years. So that is the formula that we'll be using. Please note again that this formula is the formula for amount and not for compound interest. What students get usually confused is, we have a formula for simple interest, but we have a formula for the amount when compound interest, the technique or the method of compound interest is applied. So the two formulae are not essentially analogous to each other. We have 2 different formulae, one for simple interest and the other for the compound interest amount. So please keep that in mind. So now let's go back to the sum that we were talking about. So what sum will amount to rupees 2,782 rupees 0.5. So what this essentially is the amount that we are considering. So that's good. That's the formula that we have. And we have 2 years at CI. So that's the formula that we are considering if the rates are 5%. So in the first year, we have 5%. So we replace R1 with 5. And in the second year, we have 6%. So we replace R2, that is the rate of interest in the second successive year, as 6. So we have 2782.50. That's the amount that has been given to us. And we have to find out the sum. So we need to find the principal or the capital that we have invested. So that's the unknown variable P that we have to find out the value of. And we put the value of R1 equals 5 and R2 equals 6. And as you can see, this is a equation. This is a very simple equation in P. So what you essentially do is you add, so this gives you 105 by 100. This gives you 106 by 100. You just divide 2782.50 by 105 and you can multiply with 100 and you can do the arithmetic adjustments and manipulations and you'll get P to be 2500. So this is not exactly a difficult sum. What you need to find out is the formula and there's a little bit of arithmetic manipulations. That's it. So the next sum is amount at CI calculated yearly on a sum is rupees 1,250 in 1 year and rupees 1,375 in 2 years. Find R. So in this sum, my unknown variable that I need to find the value of is R. So that's the rate of interest. Now, as we know, in case of simple interest, the principal remains the same throughout my period under consideration. So the calculations of simple interest and amount, they follow the same pattern. But in case of compound interest, since every time the amount changes and the principal changes every time, so there are certain complications that arise when I'm calculating the magnitude of the simple interest, calculating the magnitude of the interest specifically. So this sum essentially exploits that portion or that part of the concept of compound interest. So let's read the sum again. Amount at compound interest calculated yearly. So that's one part. We consider annual compound interest, like the interests are calculated on a yearly basis. So once a year on a sum, on a particular sum. So they haven't specified any sum as such. So let's keep that P if we do need it. Is rupees 1,200 in 1 year and rupees 13,000 rupees. So this 1,250 in the first year and it's 1,375 in the second year. So what we essentially have is, if you take it into account, let's say we had some principal P in our first year, and when I calculated the interest and I found out the compound interest for the first year, my amount was about, say, this much. As you know, the amount keeps on increasing, and the next time the principal becomes this, so that the amount for the previous year becomes the principal for the next year. So next time my principal becomes this. So that's my amount for the second year, which is my principal for the third year. So it keeps on progressing that way. Now, the concept that amount equals principal plus interest, that concept essentially does not change. That this concept that amount is the sum of principal plus interest, that remains the same no matter what form of interest we are calculating, whether it be simple interest, whether it be compound interest. That concept, the amount equals principal plus interest, that concept doesn't change. So if that is the case, then we can say that interest is essentially amount minus principal. So we know that this principal for that particular year will be amount of the previous year. So interest is the amount for that year minus principal for that year. So if I consider, let's say we have 2 years, so let's consider I2. So the interest for the second year is the amount for the second year minus principal for the second year. Now we know this amount, the principal for the second year is essentially amount for the previous year. So we can write it as amount for that year minus amount for the previous year. So what we boil down it to is, if amount is equal to principal plus interest, which is available, which is applicable for any case, we have interest of that year. So let's take interest of the second year equals amount of that year minus principal of that year. And we said that principal of a current year is the amount of the previous year. So A2 minus P2, amount of second year minus principal of second year, is A2 remains A2. So that's amount of this year, amount of the current second year, minus P2 can be written as amount of the previous year. So principal of the second year can be written as amount of the first year. So P2 can be written as A1, that's the amount of the first year, amount of the previous year, when we are considering that the second year is the current year. So I2 is essentially A2 minus A1. So you see, the interest of the current year is the difference between the amount of this year, the current second year, minus the amount of the first year. Now, if we look back at the sum, on a sum, amount for the first year is rupees 1250. So isn't that A1 that we are considering? Amount for the first year that we have considered, that's essentially A1. So we have A1, which is 1250. And the amount for the second year is rupees 1375. So this is essentially A2. So what you see, the interest calculated for the second year is essentially the difference between the amount on the 2 years. So that's what I've written. Difference between amounts is the interest, that's the I, for the second year. So it's not simple interest as such, so you can avoid writing simple interest. So yeah, so the interest for the second year, I, that's 125, because you see, I skipped that step. I deducted 1250 from 1375. So that's the interest for the second year is essentially 1375 minus 1250. So if you calculate, you get 125. So that's the interest for the second year. Now what I do is I use the calculation for simple interest. So that's the part of the compound interest that is being calculated on simple basis. So that's, we know simple interest is PRT by 100. If I adjust it mathematically, I get R equals SI into 100 by P into T. So that's SI equals PRT by 100. If I put R on one side and I push everything else on the other side of the equality sign, I get R equals SI into 100 by P into T. So what I do is this SI that I used, it's not exactly SI to be precise, but we use that formula so that we replace SI with 125, 100 remains 100. The principal amount is essentially 1250, and the time is, since we are considering the difference between the first year and the second year, rather the second year and the first year, so we have essentially an interval of 1 year that we are considering. So we put T equals 1. So we cancel out 0 on this side, and yeah, going by the calculations, you get R equals 10%. So essentially, we get rate of interest to be 10%. So amount at CI calculated yearly on a sum is rupees 12,000. Why am I saying 12,000? So it's rupees 1,205.50 in first year and rupees 1,375 in 2 years. So the rate of interest comes out to be 10%.